Exercise 7.2, Problem 7, discussion. A lamp post stands at the center of a circular park. Let P and Q be the 2 points on the boundary such that PQ subtends an angle 90 degrees at the foot of the lamp post, and the angle of elevation of the top of the lamp post from P is 30 degrees. If PQ is 30 meters, then find the height of the lamp post. It's quite confusing, isn't it? But anyway, let's note down. It's a circular park. The lamp post stands at the center. Okay, P and Q are 2 points on the boundary, which means on the circle. Okay, and it subtends at 90 degrees at the center, at the foot of the lamp post. Okay, then the angle of elevation of the lamp post is 30 degrees from P. PQ is 30 meters, and we are asked to find the height of the lamp post. So let's draw a simple diagram. So this is the circular path. Okay, park. Now this is the center. Of course, it doesn't look so. It's slightly distorted. Some mistake with our drawing actually. Okay, it's not exactly the center, but let's take that as a center. So A is the center, and this is the lamp post AB. You have to draw bit by bit. Okay, maybe the next time I'll do it in sequence. Actually, I'll show the drawing sequence also in the next version. So AB is the lamp post, correct? And this is the circle, and P and Q are the 2 points on the boundary of the park. Okay, so this is the whole thing is a park, and this is the boundary, right? So P and Q are the 2 points on it, and they subtend an angle of 90 degrees. So you join this to center. This angle is 90 degrees, and this is your lamp post, and that's the foot of the lamp post. Center is also the foot of the lamp post. Now from P you look at the top of the lamp post, and it gives an angle of inclination of 30 degrees. Sorry, angle of elevation of 30 degrees. From here, if you look up to the top of the lamp post, you get 30 degrees. So angle of elevation is 30 degrees. Right, and they're given PQ is 30 meters, right, and we're asked to find the height of the lamp post. So if you want to find the lamp post height, okay, you need at least one side of this triangle PAB. Okay, this is the hypotenuse, because this angle is also 90 degrees, right? So this is the hypotenuse. We should know the hypotenuse, or we should know this side, and we know we need to find this side. So we don't have any of these sides, right? So we have to find first AP, then only we can use this angle and this side to calculate this side. Okay, so first step is to calculate AP. Now look at this triangle APQ. It subtends an angle of 90 degrees, so which means, and AQ equal to AP, that is radius. So both the sides are equal, which means these angles are equal. Am I right? Because if the sides are of equal length, it's the angle opposite to it are equal. Okay, so this angle and this angle is equal. So if you know, let's put it x and x. So x and x is 2x, but you know this is 90 degrees. Total angle of the triangle is 180 degrees. So 180 minus 90 is 2x. So x will be 45 degrees. So these two angles are 45 degrees. You got it? So this angle is 45, this angle is 45. But this is again a right triangle, PAQ. Right? This is a right angle. And we know this is a hypotenuse. We need to find AP. So this is unknown, this is known, and this is a known angle. So what's the relationship between this angle, this unknown side, and the known side? Sine 45. Sine 45 is opposite by hypotenuse. So using sine 45, that is which is opposite AP by PQ, that is 30 degrees, you will be able to calculate AP. Once you calculate AP, then AB can be calculated. So how will AB be calculated? You have to find a relationship in this side, this side. This is known side now, this is the unknown side, and this is the angle. What is it? Tan 30. Tan 30 is opposite by adjacent. So you know tan 30, you know this side, which means you can calculate this side. Okay, so that is how this is. Two problems in it actually. First problem, you'll have to find AP using this information. Then after that, you will have to move to this triangle and calculate this side, which is the height of the lamp post. Okay, so let's list out what is given. Angle of the chord at the center PQ, that is 90 degrees. Okay. Then, I think, what else? I think we have missed out. The angle of elevation is 30 degrees is given. PQ is given 30 meters. Please list it out actually. I missed it. I've underlined it here. You need to list it out. I'll change it later. And we need to calculate the height of the lamp post. Okay, the formulas which will be used is sin theta equal to opposite by hypotenuse for this triangle, and then tan theta will be used for this triangle, that is PAB. Okay, right. First step, draw the rough diagram, label and mark the diagram with given values. So that is what you have done. You have done this is the circular path, this is a lamp post at the center, and these are the 2 points on the boundary. Join them to the center, and that angle is 90 degrees. Okay, and they have given from P, if you look at the top of the lamp post, that is 30 degrees. They have given the angle of elevation from P is 30 degrees. So this angle, okay, that is from here, angle APB is 30 degrees. Then since this is 90 degrees and you know these two sides are equal, these two will be 45 degrees each. Okay, now we have done that. Next, find angle AQP and APQ. That's what I said. So we need to find APQ and AQP. As I said, these two are equal sides. So these two angles will be equal. This is already 90. So the remaining angle in the triangle is 180 minus 90. So that is 90. 90 divided by 2. So these two angles are 45 degrees. Then in angle APQ, substitute AQP, in the triangle APQ, substitute the value of theta, that is triangle AQP, that is 45 degrees. Apply sin 45. You will get your opposite, which is AP divided by hypotenuse 30, and you will be able to calculate AP. Sin 45 is AP by PQ. Sin 45 is AP by PQ. Right, you might think, why not use sin 45? This sin 45 will get you AQ, but getting AQ does not solve anything because we need AP. Then only we'll be able to calculate, use this value and this angle and calculate this height of the lamp post. So we'll have to use this sin 45. Okay, sin 45 is opposite by hypotenuse, that is AP divided by PQ, from which you can calculate AP. Next, in triangle BAP, tan 30 is opposite by adjacent, that is AB divided by AP. AB is the height of the lamp post and AP we calculated in the previous step, and tan 30 we know. So using this relationship, this we know, okay, and AP we just calculated, from which AB can be calculated, which is the height of the lamp post. Okay, so it's two steps there. So let's go to the solution. You see the solution and then try to do it on yourself. Okay, so let PQ be the points on the circular boundary. A is the center of the park and AB the lamppost, right? AB is the lamppost, A is the center of the circle, and this is the circular park, and P and Q are the 2 points on the boundary. You join them and you get angle 90 degrees, and this is the angle of elevation 30 degrees from P to the top of the lamppost, and this length PQ is 30 meters. Okay, right, so up to this point you have come. Then AP equal to AQ. So now take this, consider this triangle APQ, triangle APQ, AP equal to AQ. As a result, this angle will be equal to this angle. Okay, any side, if they are equal lengths, means so the angle opposite to them will be also equal. So this angle and this angle will be equal. But as I said, the balance angle is, this is already PAQ is 90 degrees. So the leftover is only 90 degrees because the total angle of a triangle is 180. So 180 minus 90 gives you 90. So 90 divided by 2 will give you 45. So these two angles are 45 degrees. Right. Now take triangle APQ, and sin 45, because we want to calculate this side. This side is unknown, which we want to calculate, and we know this side and this angle. So the relationship between this angle, this side, and the unknown is sin 45. Sin 45 is opposite by hypotenuse, that is AP by PQ. AP by PQ is sin 45, and sin 45 is 1 by root 2. AP is the one we need to calculate, and PQ is given as 30. So AP by 30 equal to 1 by root 2, or AP will be equal to 30 by root 2, and 30 by root 2 multiply numerator and denominator by root 2. So you'll get 30 root 2 by 2, that is 15 root 2 is the AP. Now you've calculated AP. The next step will be, you'll have to calculate AB in this triangle BPA. and this is known. This is what we want to calculate, and this angle is known. So because you say it's given here, if the angle of elevation of the top of the lamp post from P, from here if you look at the top, that is angle of elevation, right? That is 30 degrees. So this angle and this known side and this unknown side, what is the relationship? Tan 30. Tan 30 is opposite by adjacent, right? So in this triangle PAB, tan 30 is opposite AB divided by AP. Right, now you do the substitute. Tan 30 is 1 by root 3. AB is the one we need to calculate. AP we just calculated it to be 15 by root 2. So AB will be 15 by root 2. It goes up. So 15 root 2 by 3. You multiply root 3 by root 3. So it will get 15 root 6 by 3. 3 will go here 5 times. So it's 5 root 6 meters. So the height of the lamp post is 5 root 6 meters. Okay. So I hope I made it clear. If not, please go through one more time. It will become clear. Thanks for watching this video.